Passing the store via context. In the last section, we created a store and passed it all the way down the component tree from the app component to the color list component. This approach required that we pass the store through every component that comes between the app and the color list. Let's say we have some cargo to move from Washington, D.C., to San Francisco, CA. We could use a train, but that would require that we lay tracks through at least 9 states so that our cargo can travel to California. This is like explicitly passing the store down the component tree from the root to the leaves. You have to lay tracks through every component that comes between the origin and the destination. If using a train is like explicitly passing the store through crops, then implicitly passing the 1 Dan of Ramu, Redux extracting container components, egghead.io. Stored via context is like using a jet airliner. When a jet flies from DC to San Francisco, it flies over at least 9 states, no tracks required. Similarly, we can take advantage of a React feature called context that allows us to pass variables to components without having to explicitly pass them down through the tree as properties.1ne. Child component can access these context variables. If we were to pass the store using context in our color organizer app, the first step would be to refactor the app component to hold context. The app component will also need to listen to the store so that it can trigger a UI update every time the state changes. Import crop types component from React. Import sort menu from /sort menu. Import color list from /color list. Import add color form from /add color form. Import sort function from /lib/array helpers. Class app extends component. GetChild context. Return. Store this .props.store. Component will mount. This .unsubscribe equals store.subscribe. Equals this .force update. Component will unmount. This .unsubscribe. Render. Const colors sort equals store.getState. Const sorted colors equals colors.sort function sort. Return equals app / colors equals sorted colors / app.prop types equals store prop types.object.is required. App.child context types equals store prop types.object.is required. Export default app first. Adding context to a component requires that you use the getChild context life cycle function. It will return the object that defines the context. In this case, we add the store to the context, which we can access through props. Next, you will need to specify child context types on the component instance and define your context object. This is similar to adding prop types or default props to a component instance. However, for context to work, you must take this step. At this point, any children of the app component will have access to the store via the context. They can invoke store.getState and store.dispatch directly. The final step is to subscribe to the store and update the component tree every time the store updates state. This can be achieved with the mounting lifecycle function. See mounting lifecycle on page 142. In component will mount, We can subscribe to the store and use this .force update to trigger the updating life cycle, which will re-render our UI. In component will unmount, we can invoke the unsubscribe function and stop listening to the store. Because the app component itself triggers the UI update, there is no longer a need to subscribe to the store from the entry.forward/index.js file. We are listening to store changes from the same component that adds the store to the context app. Let's refactor the add color form component to retrieve the store and dispatch the add color action directly. Const add color form equals props, store equals. Let title, color. Const submit equals e.prevent default. Store.dispatch add color title.value, color.value. Title.value equals. Color.value equals 0000000. Title.focus. Return. Equals add color on submit equals submit. Ref equals input equals. Title equals input. Type equals text. Placeholder equals color title. Required /. Ref equals input equals. Color equals input. Type equals color required / Add. Add color form dot context types equals. Store prop types dot object. The context object is passed to stateless functional components as the second argu. Met after props. We can use object destructuring to obtain the store from this object directly in the arguments. In order to use the store, we must define context types on the add color form instance. This is where we tell React which context variables this component will use. This is a required step. Without it, the store cannot be retrieved from the context. Let's take a look at how to use context in a component class. The color component can retrieve the store and dispatch rate color and remove color actions directly. Import prop types, component from React. Import star rating from ./*rating. Import timeago from ./timeago. Import FA_trash from React icons /lib/fa/trasher. Import rate color, remove color from /actions. Class color extends component. Render. Const ID, title, color, rating, timestamp equals this dot props const store equals this dot context return. Class name equals color style equals this dot style. Title. OnClick equals. Store.dispatch. Remove color id. / equals color. Style equals background color. Timestamp equals timestamp / To React docs, context. Star selected equals rating. On rate equals rating equals. Store.dispatch. Rate color id, rating. / color.context types equals. Store prop types dot object. Color.prop types equals. ID prop types dot string dot is required. Title prop types dot string dot is required. Color prop types dot string dot is required. Rating prop types dot number. Color dot default props equals. Rating 0. Export default color list is now a component class and can access context via this dot context. Col. calls are now read directly from the store via store.getState. The same rules apply that do for stateless functional components. Context types must be defined on the instance. Retrieving the store from the context is a nice way to reduce your boilerplate, but this is not something that is required for every application. Dan Abramov, the creator of Redux, even suggests that these patterns do not need to be religiously followed. Separating the container and presentational components is often a good idea, but you shouldn't take it as dogma. Only do this when it truly reduces the complexity of your codebase. 2 Presentational versus container components in the last example. The color component retrieved the store via context and used it to dispatch rate color and remove color actions directly. Before that, the color. 3 Redux docs, presentational and container components. 4 Dan Abramov, presentational and container components. Medium, the 23rd of March, 2015. List component retrieved the store via context to read the current list of colors from state. In both examples, these components rendered UI elements by interacting directly with the Redux store. We can improve the architecture of our application by decoupling the store from components that render the UI. 3. Presentational components are components that only render UI elements. 4 They do not tightly couple with any data architecture. Instead, they receive data as props and send data to their parent component via callback function properties. They are purely concerned with the UI and can be reused across applications that contain different data. Every component that we created in Chapter 6, with the exception of the app component, is a presentational component. Container components are components that connect presentational components to the data. In our case, container components will retrieve the store via context and manage any interactions with the store. They render presentational components by map. Ping properties to state and callback function properties to the store's dispatch method. Container components are not concerned with UI elements. They are used to connect presentational components to data. There are many benefits to this architecture. Presentational components are reusable. They are easy to swap out and easy to test. They can be composed to create the UI. Presentational components can be reused across browser applications that may use different data libraries. Container components are not concerned with the UI at all. Their main focus is connecting the presentation components to the data architecture. Container components can be reused across device platforms to connect native presentational components to the data. The add color form, color list, color, star rating, and star components that we created in Chapter 6 are examples of presentational components. They receive data via props, and when events occur, they invoke callback function properties. We are already pretty familiar with presentation components, so let's see how we can use them to create container components. The app component will mostly remain the same. It still defines the store in the context so that it can be retrieved by child components. Instead of rendering the sort menu, add color form, and color list components, however, it will render containers for those items. The menu container will connect the sort menu, new color will connect the add color form, and colors will connect the color list. Render return equals app // // Anytime you want to connect a presentation or component to some data, you can wrap that component in a container that controls the properties and connects them to data. The new color container, menu container, and colors container can all be defined in the same file. Import prop types from React. Import add color form from ./UI/add color form. Import sort menu from ./UI/sort menu. Import color list from ./UI/color list. Import add color, sort colors, rate color, remove color from /actions. Import sort function from /lib/array helpers. Export const new color equals props, store equals. On new color equals title, color equals. Store.dispatch add color title color. / New color.context types equals. Store prop types.object. Export const menu equals props, store equals. Sort equals store.getState.sort. On select equals sort by equals. Store.dispatch sort color sorted. / Menu.context types equals. Store prop types.object. Export const colors equals props, store equals. Const colors, sort equals store.getState. Const sorted colors equals colors.sort function sort. Return. Colors equals sorted colors. On remove equals ID equals. Store.dispatch remove colored. On rate equals ID, rating equals. Store.dispatch rate colored, rating. / colors.context types equals. Store prop types.object. The new color container does not render UI. Instead, it renders the add color form component and handles on new color events from this component. This container component retrieves the store from the context and uses it to dispatch add color actions. It contains the add color form component and connects it to the Redux store. The menu container renders the sort menu component. It passes the current sort property from the store state and dispatches sort actions when the user selects a div. Print menu item. The colors container retrieves the store via context and renders a color list compo. Link with colors from the store's current state. It also handles onRate and onRemove events invoked from the color list component. When these events occur, the colors container dispatches the appropriate actions. All of the Redux functionality is connected here in this file. Notice that all of the action creators are being imported and used in one place. This is the only file that invokes store.getState or store.dispatch. This approach of separating UI components from containers that connect them to data is generally a good approach. However, this could be overkill for a small project, proof of concept, or prototype. In the next section, we introduce a new library, React Redux. This library can be used to quickly add the Redux store to context and create container components. The React Redux provider React Redux is a library that contains some tools to help ease the complexity involved with implicitly passing the store via context. This library is also brought to you by Dan Abramov, the